All right, so now that you're comfortable, or I hope you are, with evaluating functions at a given number, evaluating function expressions based on their graphs, and reading a graph and creating a function from the graph, we're going to look at word problems, creating a function from the word problem and graphing that. So this example is taken straight from Khan Academy, hence the strange name. I'm just going to call her Miss A. So this Miss A is mowing lawns for a summer job, and for every mowing job she charges an initial fee of 15 bucks and plus a constant fee of 10 bucks per hour of work. 15 is going to be our starting point, our y-intercept on the graph. This is the function we're going for, and that's an important number here. That's the rate. So then function f of t, phi as a function of time, we'll have 15 as an independent constant number that doesn't depend on our variable, and then 10 is our rate times t, so 10t. Now we need to graph this function. The independent variable is t in hours, and then the dependent variable is phi in dollars. Now how do I choose my scale? Let's see, they want me to have 5 hours. Well, I'll just go, this is 1 hour, then that's 2, 3, 4, and 5. So that's my 5 hours. And then vertically, for 5 hours, if I were to put 5 hours in here, that would give me 50 plus 15. That's going to be 65. So I need to have 65 fitting in here. If I choose this to be 10, so this is 10 bucks, then that's 20, 30, 40, 50, 60, 65. Yeah, I have this. I just need to erase this part so it's not in the way, and I have enough room to graph this. So let's say I have 3 hours in mind. So how much would she charge in 3 hours? If I put 3 in here, that will give me 10 times 3 is 30 plus 15 is 45. So then at 3, she will charge 20, 30, 40, $45 right here. All right, so my starting point is 15 right here. So then I take a straight edge and graph through like that. All right. Then the question in the problem is how much she would charge for 5 hours of work. Well, then let's see. 5 hours. Boom, 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 boom. From the graph, it tells me that it's going to be $65. Well, let's check algebraically. If I were to evaluate this function at 5 hours, then this would be 15 plus 10 times 5, 15 plus 50, 65. Why? Well, what do you know? We are correct. Let's move on to the next problem. So here we have a lake near the Arctic Circle. The lake has ice on it, and the initial thickness is 2 meters, and then when warm months, when spring arrives, the warm air gradually melts the ice at this rate, 0.15 meters every week. And we need to write the function t of w, where t stands for thickness, and then w stands for the number of weeks. So t of w, we start at 2 meters, and then it decreases, so I'm going to put a minus. The rate is 0.15, and then w for weeks. So when I start graphing this, w goes here, that's the independent variable, t goes in here. How many weeks do I need? I need 10 weeks. Well, I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's 10 weeks right here. Now, how should I choose my scale on t? I have 1, 2, 3, 4, 5, 6. Right, let's say this is 2 meters. Then this would be 1 meter. All right. And then I need to figure out how to graph this. I know that my starting point is 2. So that's my starting point right here. So to graph this, I could choose an intermediate point of, I don't know, 1, 2, 3 weeks or something like that. Now, let's go for 10 that they ask us in the question anyway. How thick will the ice be after 10 weeks? Well, let's go ahead and figure out. T of 10 equals 2 minus 0.15 times 10. So that's 2 minus 1.5. It's 0.5. Well, where is the half of a meter? It's right there. So at 10 weeks, it's going to be at this. All right, so then I take a straight edge and do it like that. We looked at our data. We had the initial 2 meter thickness. That's right here. So that's 2 meters. We created the function using the rate of 0.15. So if I were to choose and figure out this slope should be negative 0.15. Well, is it? Let's look. It dropped from 2 meters to 0.5 meters. That's a drop of 1.5. In the run is 10 weeks divided by 10, so that's minus 0.15. So everything is as it should be. The next example. So we have this travel agency charging people for climbing Mount Kilimanjaro. And they are charging you a flat rate of $100 and then 30 cents. Now here's the culprit. We have 100, which is in bucks, and we have a 30, which is in cents. Now you cannot use two different values for units. You need to have the same unit. So we're going to take 30 cents and we're going to convert them to dollars. That will be 0.3. So then my function of phi as a function of meters is going to be original $100 plus 0.3 per meter. And then the graph, that's meters, and that would be F for phi in bucks. And let's see, they want us to figure out 3,000 meters. So it doesn't make sense to graph it by meters. I'm going to go by thousands. I'm going to say I'm going to go by fives. So this is 1,000, then 5 boxes to the right is 2,000, and then this would be my 3,000 meters. As far as height goes, that's in bucks. So I'm going to start at $100. Well then, how much will the charge be at this point? 100 plus 0.3 times another 100 times 1,000. That's going to be 300. So that's 100 plus 300. That's going to be 4. So how much will it be for 3,000? 100 plus 0.3 times 3,000. This will be 100 plus 3 times 3 is 1,000. 3 times 3 is 9. 9,000 minus 1 0, so it's going to be 900. So that's going to be $1,000. This is 100. Then this is 500. 5 boxes higher is going to be $1,000. Let's check. According to our function that we created, this graph should have 0.3 for a slope. Does it have it? Our rise here, I'm going to use this triangle, is 900, and our run is 3,000. So 900 over 3,000, chip off 2 zeros as is. We have 9 over 30 divided by 3 to simplify it. So it's going to be 3 over 10, which is 0.3. So our slope is as it should be, 0.3. Our function graph is beautiful. Our answer is correct. We're all good. The next one. Edison painted her room. She had 50 square meters to paint, and she painted at a constant rate of 7.5 square meters per hour. Write and graph A of t as a function of time. So I'm going to show you 2 ways to graph this. We can write this function 2 different ways. If we're saying that A of t, where A is area that is still empty and not painted, we can say that this is a negative 50 and then plus 7.5 times t per hour. If, however, we are using A for the area that is, so right now, so basically think about it this way. For the first one, I'm saying negative 50. This is still empty, and then this would be plus 7.5 t. My other view of this is going to be, here's my area, which I consider to be 50, and then minus this area that is already painted. So whichever you prefer, it's up to you. Either way will work. It's just the way you graph it is going to be different. So what I'm going to do, I'm going to color code it differently. So let's make this pink. So if I am graphing the pink function right now, then I will start at 50. So I'd say 1, 2, 3, 4, 5. So that's 50. And then let's say 1 hour, 2 hours, 3 hours, 4 hours. I'm going to go 4. In 4 hours, 7.5 times 4 is 30. 30 is what I am subtracting. So then 50 minus 30 is 20. So the person will still have to paint this much, 20 feet, 20 square feet. Then my starting point is 50 and I'm going down. So you're thinking that's the area that is still left to be painted. Area. And that area is the one that is unpainted yet. If I am graphing, however, the purple one, then I'm going to start at negative 50. That's the area that is still remaining to be painted, and I'm thinking of it as the negative painted area. And then my increase will be the painted area. Well, how much will I have painted in 4 hours? 30 meters squared, or square feet. What is it? Square meters. So then that is what my graph will look like. So what I'm showing is that the unpainted area is decreasing. Either way, it works perfectly fine. Slope is either positive or negative. So depending upon how you want to graph it, as long as you understand what you're graphing, unpainted area, and you think about it as a positive thing, somewhere you can still stand. So that's the good thing. This is also unpainted area, but you're thinking about it in a negative way. You're thinking, oh my goodness, I still have to paint it. Ultimately, you have the same two graphs. They just have a positive or a negative starting point, and hence a positive or a negative slope. Either way works. The question is, how much area is left to paint after 2 hours? Well, 2 hours here or there. According to this, the remaining area, this would be negative 35, and this would be 35. Either way, negative 50 plus 7.5 times 2, that's negative 50 plus 15, negative 35. 50 minus 7.5 times 2, 50 minus 15 is 35. Either way, your answer to the question will be the same. 35 square meters are still left to paint.